Today, I'd like to talk about the imprecise and confusing names that are used for electrical switches, at least here in America. And I'd like to introduce the names that I use, the ones in my mind that I've used for as long as I can remember, because I think they merit some consideration. Okay, let's begin. You'll ordinarily hear this switch referred to as a single pole. It's a switch device, or you could call it a control or interrupt device. Unlike a load device, it does not consume energy. It simply allows the energy to pass through it. In the field of electrical work, you might hear definitions like these for the word pole. 1. A point of connection, or a terminal. 2. A hot live connection, that would ordinarily be a hot entry terminal. 3. The number of separate circuits that a switch or circuit breaker can control. Does this switch satisfy definition number 1? Maybe. It does have 3 points of connection, terminals, line, load, and ground. Does this switch satisfy definition number 2? Yes. One gold entry terminal will be live at all times. The other gold exit terminal, however, will be live or dead, depending on the switch position. Does this switch satisfy definition number 3? Yes, but with conditions. First, the presence of a single entry terminal and a single exit terminal, and common sense, informs us that this switch controls one single circuit, unless it is a switch that controls a relay, which in turn would likely control multiple circuits, but that's ordinarily not the case. As such, we could conceivably refer to this switch as a single circuit switch. The only problem here is that further along in this study, we will see that the so-called three-way switch and the so-called four-way switch are also single circuit switches. All in all, then, the term single pole yields very little useful information about this switch. Additionally, this switch has 2 ways as switches go, on and off. Yet we do not refer to this switch as a 2-way switch, which is odd. What we can safely say about this switch is that it is indeed one single circuit. Only one circuit is being switched. 2, single throw. There is only one possible outcome connection or current path. And 3, single break. The toggle arm breaks the circuit at only one point. Thus far in this study, the key takeaway, aside from the fact that the name single pole stinks, is the little discussed fact that this switch is independent. That is, it can stand alone. It works just fine on its own. So what about the so-called three-way switch? Well, let's see. Of all the great mysteries in electrical jargon, there are few terms as baffling as the term three-way. Personally, I think this name stinks worse than single pole. So let's put it through its paces. This switch is sometimes validated as a three-way because of the commonly accepted 3 current states. Traveler 1 is live, traveler 2 is live, or there's no current. In other words, neither traveler is alive. The flaw in this thinking is due to the fact that the no current dead state can be caused by the other three-way switch in the circuit. With 2 three-way switches in play, the three-way team has 4 possible scenarios, and those scenarios are realized by the 4 different switch positions that are possible. Up, up, down, down, up, down, and down, up. As such, the single break that would affect the no current or dead state can be caused by a break in either traveler 1 or traveler 2. For practical purposes, this simply doesn't matter. If the switches work correctly, no one cares. But for theory purposes, this feature can't be ignored. That's because all 3 of the switches featured in this study were given idiotic names from the start. so adding more imprecise premises will not help matters. So what can we safely say about the so-called three-way switch? First, it is indeed a single circuit device. Second, it has 4 terminals, not 3. You might say, but one terminal is only a ground. And you're correct. But if code categorically states that this device must have that terminal, then we cannot ignore it. Third, it is a single break device. That is, only one break can be affected at one time. Fourth, it is a double throw device. That is, there are 2 possible output connections. Additionally, this switch, like the so-called single pole switch, could be referred to as a single circuit switch, but no one does that. And unlike the single pole switch, this switch is not a standalone switch. It is dependent. To be able to switch a load device, one that consumes energy, from 2 different locations, this switch must be paired with another 3-way switch. All in all, though, the name 3-way stinks. And that brings us to the so-called 4-way. Naturally, we ask, well, what does the number 4 indicate? 4 terminals? No, there are 5, if you include the code-required ground. Are there 4 ways or current configurations or switch combinations? No, there are 8, and they're listed here. However, as there are 4 possible on states and 4 possible off states, I will concede that the number 4 does lurk somewhere behind the vague name 4-way. To make matters worse, this switch is referred to as a double pole switch. This is false. Just like the so-called single pole and the so-called 3-way, this switch is a single circuit switch, though you won't ever hear anyone calling it that. Most people are inclined to think of this switch as a double pole because of the 2 travelers entering the switch and the 2 travelers exiting the switch. In this switch, 1 circuit is active, not 2. And in a single circuit switch leg, you cannot have 2 hot line sources at one time, though the 4 travelers hovering around the 4-way switch create the mental illusion of 2 circuits being in play at one time. They are nothing more than what I might call alternative output legs. That is, each leg is a current path option. So what can we safely say about the so-called 4-way switch? The switch is a single circuit switch, not a double pole. That is, you have only 1 circuit path energized at any given time. Mechanically, it can be referred to as double break, but energetically, it is only single break. That is, only one of the 2 toggle arms breaks the circuit at switching. It is a double throw device, but you likely won't hear anyone referring to it that way. And in the 4-way team of devices, the inclusion of the 4-way switch provides for 8 ways, not 4. So how can we fix this terminology mess? A mess that's baffled even the brightest of minds for decades and has surely overstayed its welcome. It's simple. We stop trying to name something using a method that has failed miserably. For some stupid reason, we keep trying again and again to identify an electrical device by its respective physical features alone. This does not work, period. What we need to do, actually what I did decades ago, is identify and label switch devices by their specific dedicated undeniable function. And how do we do that? We add one word, station. That's right, station. And what does station mean? Station, the place or position in which something stands or is assigned to stand or remain. That something, that switch, is there for a reason. it has right there, right where it stands, right where you installed it, a function. It performs that function at a specific location. So why not give the device a name that imparts this valuable information? Why use idiotic names that only confuse even sensible people? Why not use logical names? And here they are. These are my logical designations. Single station switch. Mainstream calls it single pole. That's what you would call it. Double station switch. That's the three-way. That's what you would call three-way. Triple station switch. That's what you would call the four-way. These are far more accurate names. Let's take a look at it. The single station switch is independent. It can work fine by itself. It's one switch, one location, and there are two switch position configurations. It's either on or off. The double station switch is dependent. Yes, it can work by itself, but it can work by itself as a single pole switch, but that's stupid. Because first of all, it would take up more space in your switch device box, and second, it would be much more expensive. So that's stupid. Anyway, so the double station switch, you need two switches and two locations. Double station, two switches, two locations. And there are four switch position configurations possible. Two will be on and two will be off. The triple station switch is also dependent. By itself, it's worthless. You need three or more switches, and there are three or more locations in this configuration. You'll need one or more triple station switch and at least two double station switches. And there are in total 8 switch position configurations. 4 will be on and 4 will be off. So there you have the names that I've used for God knows how long. These are the formal logical designations. Single station switch, independent. Double station switch, dependent. It has to work with at least another double station switch. Triple station switch, that's what you would call four-way. Now, if a manufacturer were to produce these using these really nice names, they could use as product or item codes, they could use these alphanumeric designations. Single station switch, line load. Double station switch, line 2 travelers. Triple station switch, 2 travelers, 2 travelers. It's nice and tidy. No one can get confused using these names. If you teach a young apprentice, a novice, these names right from the beginning, there'll be no confusion ever. And that's just what I think. So anyway, I'm going to toss these names out and see what happens. But I've been thinking about this for decades, a long, long time, and I think it's time to share them. So thanks for being incredibly patient, and good night.